Okay, Assalamualaikum warahmatullahi wabarakatuh and noon tu all. Okay, so kita sambung balik kita punya kuliah. Okay, chapter number 1. Lesson 1, P2, this one. Okay, kita berhenti kat mana itu? Oh, ni kiraan ni. Okay. Minit ke apa itu yang ni, this one. Okay.
Average atomic mass from a mass spectrum. So the formula to calculate average atomic mass is given as below. Qi mi over Qi, or I abbreviated it as Ki. So what is Q? What is M? So Q is...
Okay, so yang ni dah apa nama ni dah dibuat dalam tutorial masing-masing. Average atomic mass equal to the sum of Qi mi divided by the sum of Qi. Okay, so apa dia Q, apa dia M?
Refers to the relative or fraction or ratio or percentage abundance of isotopes in a...
Wajib tulis ini formula. Kalau dia minta average atomic mass ataupun relative atomic mass, wajib you tulis dia punya formula.
Mixture. While M is the isotopic mass of the element in unit U. So the average atomic mass after we do the calculation, the final answer must be in unit U or AMU.
Okay. So untuk yang average atomic mass, dia ada unit. Unit sama ada unit U ataupun unit AMU. So kalau dia suruh kira lepas normally dia suruh kira dulu average atomic mass and then later dia suruh you all kira pula relative atomic mass. Jadi untuk bahagian average atomic mass, pastikan your final answer which are unique, and then for the relative atomic mass pastikan there is no unique. Alright, carry on.
Now let's look at this example. This is the same mass spectrum as in the previous example for magnesium. So based on the mass spectrum given, calculate the average atomic mass of magnesium and relative atomic mass of magnesium. So this is the mass spectrum. Each height of line indicates the abundance, which is Q.
Yang tu lah Q-nya. 78.9, 10.0, 11.1. Itu Q. Jangan tertukar dengan mass.
So this is Q1. This is M1.
Okay, M1 there.
This one is Q2.
Okay.
And M2.
Alright.
And the last one is Q3 and M3.
Okay.
Okay, now we just have to insert all these values into the formula. So this is the formula. This symbol means total.
Total.
Total abundance multiplied with the total mass over the total abundance. So to solve this question, just insert all the values into the formula. So average atomic mass is equal to 78.9, which is the abundance, times the mass of the isotope.
Okay, so you all, masa you nak insert data ni, pastikan betul-betul lah mana satu dia punya QI, mana satu dia punya Q1, M1, Q2, M2, Q3, I punya battery. Okay, M3. Jadi dalam you punya Q dengan M tu pastikan betul-betul you ambil. Okay.
Which is 24 U. Okay, plus Q2 times M2, 10 times 25U plus Q3 times N3
Pastikan betul you masukkan
11.1
pastikan betul
times 26U
alright
over the total abundance
ni satu
Q1
lagi the sum of QI
plus
ni
Q2 plus Q3.
So
78.9 plus
okay, so kat sini kesilapan pelajar dia tersilap letak dia punya M situ. Dia letak 24 plus 25 plus 26. Salah lah. Jadinya pastikan you betul-betul insert the data. If mass make sure below and then di atasnya adalah Q darab dengan M. Okey ya. Alright.
10 plus 11.1. So the final answer here, after you press the calculator, the answer will be 24.32U. So this is where we get 24.3 in the periodic table.
U or AMU.
Next, to find the relative atomic mass.
Okay, so kat sini dia letak saja AR kan. Okay, so I nak you all tulis lah. Relative atomic mass, AR. Ataupun tak nak pakai AR tu, kena tulis fully sentence. Boleh ya? Tulis you all. Fully sentence relative atomic mass. Alright.
Magnesium, this is the equation. AR equals to average mass of one atom of element in unit U over 112 times mass of one atom of carbon-12.
Okay.
So to calculate this, just insert the values into the formula. AR equals to 24.32U. This is from the previous question.
Dapat tadi.
Over 1 over 12 times mass of one atom of carbon-12, which is 12U.
Alright.
So since the unit is the same, so we can cancel out the unit. So the final answer is 24.32. This is why relative atomic mass has no unit.
Okay.
That's all.
Okay. So kat situ fahamlah penggunaan untuk formula average atomic mass dan juga relative atomic mass. Alright. So we go to the next lecture. 1, 2, 3. This one.
Assalamualaikum and hi everyone. Welcome back to our lecture. Let's recall all the subtopics in chapter 1. So we have completed 1.1. Now we will continue with 1.2, which is mole concept. This is one part of subtopic 1.2, which is empirical and molecular formula. In this subtopic, you should be able to define the term empirical and molecular formula and determine empirical and molecular formula.
Okay, untuk yang ni pun dia biasa masa dalam exam yang ni. Define the terms empirical and molecular formula, and then determine empirical and molecular formula from mass, composition or combustion data. Alright, yang B tu yang banyak masuk dalam exam. So dia beri percentage and so on tu, dia suruh you kira dia punya empirical formula. So sini nampak soalan ni macam mudah, tapi kebanyakan pelajar I tengok masih lagi merangkak-rangkak untuk menjawab soalan ni. Rugilah yang ni. Soalannya simple je. Alright.
From mass composition or combustion data. There are two types of chemical formula, which is empirical formula and molecular formula. Empirical formula is chemical formula that shows the simplest ratio of all elements in a molecule. While molecular formula is chemical formula that show the actual number of atoms for each element in a molecule. Let's look at these examples here. Now look at the first one, which is water. So the empirical formula is H2O. and the molecular formula is H2O. Since the empirical formula is the same as the molecular formula, therefore, we know that the value of N is 1. Now let's look at the second example, hydrogen peroxide. The simplest formula is HO, while the molecular formula is H2O2.
N tu kita perlu tahulah, pasal kita nak mencari kita punya molecular formula. Normally dia beri jisim ataupun dia beri percentage. So kat situ kita akan set up the empirical formula table tu. Dia ada table ni kan. The mass table tu kan. The mass, apa lagi, the mole and the simplest mole. Yang tu. Untuk table saja tu, kalau betul memang dua markah lah. Okay, and then carry on.
It means that the empirical formula is multiplied by 2 to get H2O2. Therefore, the value of N is 2. Now, let's look at the third example, which is benzene. The molecular formula, the empirical formula is CH, and the molecular formula is C6H6.
Okay.
So we know that
benzene ni, benda-benda lah ni, hydrogen peroxide, benzene, ethyl, and then glucose. You akan belajar dalam semester yang kedua dalam organik. Benzene ni dia aromatic compound ni, ethyl triple bond. Alright.
The molecular formula is the product when empirical formula is multiplied by a number. So the number which is multiplied by CH is actually 6. So CH times 6, so we get C6H6. So N is the integer value by which we multiply the empirical formula with to get the molecular formula. Or we can also find the molecular formula if empirical formula and the value of N is given in the question. So the formula for N is molar mass of molecular formula divide with molar mass of empirical formula.
Kenapa lah formula ni?
And molecular formula is N multiply with the empirical formula.
Semua tahu yang ni kan. Alright, carry on.
So N should be integer from 1 to 3 onwards. These are the steps to determine molecular formula. To find molecular formula, first you need to find empirical formula. Next, after you found the empirical formula, you can find the value of N. And finally, only then we can find the molecular formula. There are 3 types of data that we need in order to determine empirical formula. We need mass of each element, or the percentage composition of each element, or combustion data.
So, antara tiga ni memang you all perlu tahu dah. Mass, percentage composition dengan combustion data. Alright, macam mass tu gram lah. Percentage composition tu you kena assume lah. Kalau dia bagi 25%, so total up is 100%. So you kena assume dah dia dalam bentuk gram. Kenapa? Pasal lepas ni you nak buat mole, right? Kalau nak calculate the mole, maknanya you kena adanya mass, kan? Kena ada dalam bentuk gram tu. Alright. Okay, and then carry on.
For combustion data, it will be discussed during tutorial class.
Tutorial, alright.
Let's look at example 1. Calculate the empirical formula of aluminium oxide from the masses of constituents. So, mass of aluminium is 1.08 gram.
Okay. So, sini
mass of oxygen.
Untuk soalan tutorial and so on tu, pakai highlighter. Pakailah. Kalau apa yang you suka, pastikan data-data yang given in your question tu you dalam kita gariskan. Okay, so ambil you punya highlight 1.08 gram aluminium, right? So ambil you punya highlighter, tolong highlight. Bukan apa, takut you tertinggal data. Right, tinggal data, habislah. And then dia beri apa lagi? 0.96 gram oxygen. So ambil you punya highlighter tu, highlightkan dia. Alright. Okay, carry on.
Oxygen is 0.96 gram. What is the empirical formula of the oxide? Actually, you have learned how to solve this problem during secondary school.
So table, table ni penting Buat table ni dulu. Seingat betul saja semua sekali table ni you manage to get 2 marks yang ni. Tolong buat table ni sebaik yang mungkin ataupun set up di table ni untuk kira empirical formula.
Now let's recap how to use this table. To solve this type of question, first you need mass of each element in the compound. So the mass of aluminium given in the question is 1.08 and mass of oxygen given is 0.96. Next, you need to find the number of mole of each element. So 1.08 divide with the molar mass of aluminium, which is 27.
Alright. So kesalahan pelajar kat sini kat mana? Dia dekat mass satu and then pada ada calculation of the mole tu. Dia pergi ambil bukan dia punya molar mass untuk aluminium, dia pergi ambil proton, dia substitute over there. So tolong beware lah bahagian calculation of the mole. Pastikan you ambil.
So we will get 0.04 mole.
Alright.
Do the same thing for oxygen. So 0.96 gram divide with the molar mass of oxygen, which is 16. So we will get 0.06 mole.
Okay, dapat.
Now we can get the ratio. So to find the ratio of each element, we choose the smallest number. So between 0.04 and 0.06, 0.04 is smaller than 0.06. So we will divide both number with the smallest number. So for this one, we will get 1.
Alright.
For oxygen, 0.06 divide with 0.04.
Okay, so dapat
you will get 1.5.
1.5. Alright.
So since the final answer,
okay, so sini kena tengok satu untuk for the aluminium dia dapat simplest ratio 1. Meanwhile for the oxygen simplest ratio dia dapat 1.5. Okay, so macam mana kita nak jadikan dia dalam bentuk bulat? Sama ada kita nak bundar ke apa? Okay, so kita tengok macam mana dia buat.
Is 1 and 1.5, you cannot round off the answer to the closest integer.
Okay.
So what you should do is you have to find the lowest common factor between these two numbers. So for this one, for aluminium, 1 times 2. So you will get 2.
Okay.
And 1.5 times 2. So you will get 3.
Alright.
So the empirical formula of aluminium oxide is Al2O3.
Okay.
This is a reminder to find the simplest ratio.
Tolong sini betul-betul. And notes to remember. Number our value close the whole number in order to get the simplest ratio, but you must multiply the value by a factors and number until you get a whole number. However, if the value very close to whole number, plus minus 0.01 is allowed to run off. Okay, so jangan pandai-pandai untuk bundarkan salah. Kita darab. Kalau darab dengan 2 masih lagi tak dapat nombor bundar, darablah dengan 3. Tak masih lagi tak dapat nombor yang bundar, yang dekat tu, yang hampir-hampir nombor bulat, darab dengan 4. Belum, darab dengan 5. Belum lagi, darab dengan 6. And so on. Alright. Okay.
So you cannot round off the values close to a whole number, but you must multiply by a value until you get a whole number. However, if the value is very close to a whole number, which is plus minus 0.01, then you can round off to the closest integer. Let's look at example 2 for better understanding.
Yang ni banyak ni.
Calculate the empirical formula of ascorbic acid from percentage composition by mass. So we can see that the percentage of each element is given. 40.92% of carbon, 4.58% hydrogen, and 54.5% oxygen. The molar mass is given. So from these informations, so you have to find empirical formula and molecular formula. So first you have to assume that the percentage is
So yang ni memang dia beri dalam bentuk percentage. Okey. So nak cari mol kena dalam bentuk mass. Jadi nak tak nak you all kena assume Macam contoh untuk this kind of question, assume that 100% of ascorbic acid has a mass of 100 gram. Biasanya I tulis 100.0 gram. Okey, tak apalah. Okey. So kena nyatakan dulu. Kalau dalam exam yang dulu, assume ni saja you akan dapat 1 markah. Okey Dah assume yang tu, barulah kita carry on.
Equals to the mass, so you just have to assume that 40.92% is 40.92 gram and so on.
Okay.
So from all these percentage, just insert the values into this table where you need all the mass of each element. Now let's do the same thing like the previous example. After you insert the mass, you have to find the number of mole of each element. So 40.92.
So macam I cakap tadi, tolong hati-hati. Untuk calculate the mole ni, pastikan you pergi ambil dia punya gram per mole tu. Dia punya molar mass tu. Okey, dia berapa tu?
Divide with 12, which is the molar mass of carbon. So you will get 3.41.
Per mole. Alright, 3.
For hydrogen,
ni satu lagi. Untuk you punya calculation ni, pastikanlah 4 decimal places. Maknanya 40.92 divided by 12 equal to, contoh 3.4111. Pastikan you ambil 4 decimal places. Biasakan diri dengan guna 4 decimal places. Alright. Okay, carry on.
58 divide with the molar mass of hydrogen. So you will get 4.58.
0. Alright.
And for oxygen, 54.5 divide with molar mass of oxygen.
Alright.
So you will get 3.41. Now to find the simplest ratio, you have to identify the smallest number. So 3.41 divide with 3.41. So you will get 1. Next, 4.58 divide with 3.41. So you will get 1.33.
Ini kena darab.
And the last one, 3.41
dia tak boleh round
divide
off,
with 3.41. So you will get 1. So as you can see here, we have 1.33.
Okay.
So you have to multiply with the factor which you will produce the closest integer.
Right.
So for this values,
Times
you
3.
have to multiply all the number by 3
Okay.
to find the closest integer. So you will get 3, 4, and 3.
Okay.
So the empirical formula for ascorbic acid is C3H4O3.
Okay. Alright, good.
Next, to find the molecular formula.
Okay, molecular.
So this is the empirical formula you have found just now. You have to calculate the molar mass of ascorbic acid. So 3 times the molar mass of carbon, 4 times the molar mass of hydrogen, and 3 times the molar mass of oxygen. So you will get 88.
Ni tambahan sikit you tulis molar mass of C3H4O3, tambah sikit molar mass of C3H4O3 equal to letaklah dia punya 3 times 12 4 plus 4 times 1 plus 3 times 16. Alright.
Gram per mole.
Alright, gram per mole.
To find the value of N, you need the mass of molecular formula and mass of empirical formula.
Right.
So the mass of molecular formula given in the question is 176 gram per mole.
Okay.
And mass of empirical formula is 88 gram per mole.
Right.
So from here, you can get the value of N, which is 2.
Right. So
So molecular formula is n multiply with the empirical formula. So the value of n we got here is 2 times the empirical formula, which is C3H4O3. So you will get C6H8O6 as the molecular formula.
Okey. Okey.
That's all. Thank you for
Okey.
listening.
So pergi pada okay, you all dapat apa dia punya lecture untuk today mengenai empirical formula dan juga molecular formula. Okay, so sekarang I akan stop dan dalam masa 10 minit I akan ambil your attendance. Okay, so wait for me Telegram ataupun WhatsApp. Alright. Okay.